Hi, in this video and the one that's associated with it, we want to talk about stress, strain, and something called elastic moduli, which has to do with the basically constants relating to the ratio of stress to strain. This relates to Young and Freedman's University Physics, Chapter 11, Section 4, but I've divided it into two parts. In this video, I want to introduce the ideas of stress, strain, and the constant of the ratio of those two. So there are several different kinds of stress. Stress is basically the strength of forces on an object per unit area. So there are various kinds of stress. For example, there's tensile stress. If I were to take something and pull on it on both ends, that's a tensile kind of stress. The opposite of it would be, of course, a compressive stress, where I might push on two ends of something. There's also something called bulk stress, such as you might experience if you were doing deep sea water, underwater diving, where you have water pressure on you at all points, in bulk upon you as a diver. And then there's something called shear stress, which is like the kind of stress that scissors exert when you're cutting something, a more extreme deformity at a particular point. So those are some examples of stress. It is a force exerted on an object that deforms that object in terms of force per unit area. Strain is the result. So if stress is the force, then strain is the resulting deformation, the fractional change in, say, length or the change in volume, etc. So the fractional change is the strain. Now, when the stress and strain are somewhat small, relatively small, and it depends on the kind of object you're putting the stress on. But when the stress and strain are somewhat small, when they're within certain limits, stress and strain are proportional. We've already seen this, you've already seen this in any physics textbook by this point. So, for example, in Chapter 6 of Young and Freedman's University Physics, they introduce you to something called Hooke's law when it comes to a spring. Hooke being a scientist who lived in England several hundred years ago. You might remember this from Chapter 6, for example, if you're using this textbook, where the force is proportional to the amount stretched of the spring, and it's proportional by a constant. So force equals a constant times the amount of distance it's been stretched or compressed. So that is Hooke's law in relation to a spring. Of course, you can stretch the spring so far that it breaks or loses its elasticity, so it's only within a particular parameters. And what the constant is depends on the kind of spring, for example. But in general, within certain limits, force and the distance stretched are proportional. The force of the stress is proportional to the distance it's stretched. Okay, well, Hooke's law in general, we can now generalize Hooke's law in a more general way, that stress over strain equals a constant. Stress over strain equals a constant, called here the elastic modulus. And the elastic modulus here is going to be constant for a particular type of material within certain limits. So aluminum has a certain elastic modulus and so forth. So within certain limits, stress and strain are proportional, and the stress divided by the strain equals a certain constant for that type of material. Now, finally, in this introduction, the SI, the standard unit of stress in science, is the Pascal. A Pascal, PA, is 1 Newton of force per square meter. A Pascal is 1 Newton of force per square meter. So 1 PA, 1 Pascal, equals 1 Newton per square meter. By the way, you may be familiar from somewhere else with pounds per square inch, PSI. That's another kind of measurement. It's the English, using the English system, pounds per square inch. A PSI is a much larger unit than the Pascal. So a Pascal is 1.45 times 10 to the negative fourth PSI. So we might say that a PSI is about 7,000 times bigger unit than a Pascal. It's less than 7,000. It's like 6,895 or something like that, but it's close to 7,000. So this has been a brief introduction to stress and strain as it relates to pressure per square inch and the resultant change of shape of something, stress and strain.